So let's go back and draw the picture again. The sample space with 9 outcomes.
Camera's on, Professor. We can see you.
Yeah, okay, good. Thanks. I will be right back. Okay. Okay, hopefully we will stay connected. We've got 4 and 6. Also, I want to say thank you for being patient at each of the meetings and also during this interesting semester. It's going okay so far. Luckily, we have spring break coming soon. All right, the rest of the space, we need 1, 8, 2, 3, 9, and 7. This seems a little different. We did the 6-sided die, and then we had the sample space 1 through 9. And do I have the same Venn diagram that we did together? I think so.
No, we had the 8 on the outside in the first Venn diagram.
Thank you. Let's do. I'm gonna try that. Okay. We're going to find the probability of A union B. So the number of outcomes in both sets will be 1, 2, 3, 4, 5, 6. 9 total. Let's see, you've got 2 times 3 over 3 times 3. 3 over 3 would be 1. So 2.
Would the 5 would be on the outside too, right?
Yeah, yes. That looks better. Thank you. Cool.
Thank you.
6.
What numbers do it say on the ends of B?
B, it's 4, 6, 2, 3, 9. Let's do the probability of A given B. I think this would be part C. This is given. So this is the one we've learned today. It's probability of A given B, and you use a formula. Probability of A given B equal to probability of A intersect B. oops, this is intersection.
It'd be, yeah, I was scared. I was just kidding.
So the probability of A intersect B is 2 elements in that set out of 9 possible outcomes. Divided by the probability for B, which contains 1, 2, 3, 4, 5 elements. And then divide by the total possible outcomes. Okay, 2 out of 9 multiplied by 9 over 5 to get to this. So the formula will work every time, but we'll talk about restricting the sample space. So you know that B has occurred. So you look at just that event B, and then you want to know how many times does A occur out of 1, 2, 3, 4, 5 possible outcomes. Just 2 times out of 5.
Professor, when you're finding out like how to get the answer, the both nines they just cancel out, and you're left with whatever is there, right? Like the 5 would be your answer.
Yeah, this 9, any number over itself is going to be 1. So like, you'll have, let's say if you have on the side, just in case something happens where let's do 7 over 5 times 7. 7 over 7 equals 1. And then you still have a 5 here, so 1 over 5.
Oh, okay, thank you.
Let's go into a new sample space. Okay, we have a set that contains A, B, C, D, E, F, G.
Could you
What was that?
could you repeat the, my audio was ahead of the board, so I was asking what the sample space is, but now I can see it on the screen. It updated.
Yeah, it's going to come out clear at least once it's posted to Canvas. Okay. We're going to put set A. As it contains A, B, C, F, G. Set B has B, C, D, F. We should do a Venn diagram first. The full space. since A and B are going to overlap. They share B, C, and F. This set needs, let's see, A, B, C, F, and G. B, C, D. Cool. And A, B, C, D, E, F, G. Let's find the probability of B. Okay, we look here, there's 1, 2, 3, 4 elements out of, let's see, 1, 2, 3, 4, 5, 6, 7, 8 possible. We can count from here, 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7, oops, missing something. Or did I overcount? Oh, there's just 7.
It would be 7.
Thank you. It's a good to double check. Let's find the probability of B given A. We're going to do the formula first, and then we'll talk about restricting the space. Okay, you take the probability of B intersect A. And divide by what's in the second spot, probability for A. Okay, B intersect A has 3 outcomes, so the probability is 3 over 7. I want to save our nice picture, so just rewriting what's happening here. We're going to go back to the probability for B given A equals probability B and A. Probability. Okay, where are we? 3 times out of 7. Probability for A. A has 1, 2, 3, 4, 5 out of 7. Okay, you take that top fraction, multiply by the reciprocal of the bottom fraction. And that 7 over 7 reduces to 1. You can say also that they cancel out, and you get 3/5. I think we might just move on to a new sample space. Let's see, any questions though? Okay. And actually, before erasing the picture, we'll talk about thinking through what happened. So B given A. you know that A has happened. So we block out everything else except for event A, or you restrict the whole space down to just that set A. Now, how many times does B occur knowing that A has occurred? Okay. This is set B here, which has 3 elements out of 1, 2, 3, 4, 5 possible. So 3/5 was the answer. The new space has more letters. It's RSTWXYZ. What's this? Set A contains T and Z. B contains WXY.
Just to confirm, in the set, U is not included, right? Letter.
Oh yeah, Q,
It goes
C.
simply to
Yeah,
RST and then to W.
yeah, it left out the U. Thank you. QRST, UV. Yeah, U and V are gone. And we get up back to WXYZ. Okay, first question is, are A and B disjoint? We will also do a Venn diagram. So that'll be kind of like scratch work, and then the main focus is, are they disjoint sets? So A contains T and Z. B has WXY. And there are no common elements. They are disjoint. A and B are disjoint. I like to say, since they share no common elements. We will find, let's find the probability of B. Probability of B. Oh, did I get my other, I need my other elements. Oops. It's R, S, T, W, we've got X and Y and Z. Cool. So B has 3 outcomes. In the full space, we've got 1, 2, 3, 4, 5, 6, 7 outcomes. Cool. Same size. We want, for part C, the probability of A given B. So we'll use the formula. Take probability of A given B as probability A intersect B divided by probability of B. This one first. So probability for A intersect B is 0 elements out of 7. Probability for B has 3 elements. Oh, we did this one. 3 elements out of 7. 0 over 7 multiplied by 7 over 3. 0 times 7 is 0, and then 0 divided by any number, but 0 divided by 21 is 0. So that's the answer.
Is that just saying that 0 saying that A and B don't influence each other in either way because there's nothing that's related between the two?
Yeah, that's good. And like these events don't have an effect on each other. It's a perfect way to say it. But also, like we did before, you know that B occurs, so we restrict the space to just that part. Let's move this over. Okay, so we focus on event B. That's already occurred. So how many times can event A occur out of B? Well, 0 times out of 3. Let's find the probability of A union B. And we'll keep on going to new examples. All right, A union B. Be both sets which will have 1, 2, 3, 4, 5 outcomes out of all 7. Let me see. Okay, when you find A given B and it will, if the intersection of A and B is 0 or is empty, so the probability will be 0. So that will happen every time. You'll get a 0 every time you have disjoint sets. And you have to get the probability of B given A or A given B. That'll happen. It's a very good question. Okay, so what we're going to do, did we get this one? Yes. We're going to make a table and then do similar probabilities from the table. we've got A, B, and the total. X, Y, total. The numbers for the table would be 8, 4, 6, 7. All right, let's find totals. So 8, 9, 10, 11, 12. This would be 13. This way, so 15, 14 here. And then 11 right there. And if we add this way and that way, we should have the same number. So 25. This would be a 5 and a 25. And try to remember that that's the size of the full space. That's the size of S. Okay, we'll find the probability for A. Okay, so get to event A, find its total, and then divide that number, 12, by the full total of the whole space. 12 over 25. Okay, let's do another one like this. Let's do the probability for Y. And Y has 11 possible outcomes, and then take that number out of the total possible outcomes. Let's find the probability of X intersect B. We will find event X, which is this part. And event B goes this way. And it's X and B. So right there where they intersect. Six times out of the total. Let's find the probability of A given X. Take the probability of A and X and divide by the probability for X. Oops, cool. Probability for A intersect X. So find A and where it meets with X, which is right here with 8. Out of the total. Okay. Divide by the probability for X, which is 14 out of 25. So 8 over 25 multiplied by 25 over 14, and the 25s will cancel. Yes, we could write it down. Like it reduces down, leaves a 1 right there, and you've got 8 over 14. Which is 2 times 4. This is 2 times 7. So you can do this again. 2 over 2 is going to equal 1. And that leaves 4 over 7. Oh no. Guys,